Okay, our next lesson is on linear and nonlinear expressions in X. So a symbolic statement in X with an equal sign is called an equation in X. The equal sign divides the equation into two parts, the left side and the right side. And the two sides, the left and the right, are called expressions. So you have an expression that equals an expression. For the sake of simplicity, we will only discuss expressions in X, but just keep in mind that we can write expressions with any symbol, whether it be K or A or S or whatever. But we're just going to go ahead and just call it X. The following chart contains both linear and nonlinear expressions in X. In your math journal, sort them into two groups and be prepared to explain what is different about the two groups. So here is the chart. You have 9 expressions. See if you can split them up into linear expressions in X and nonlinear expressions in X. And explain your reasoning for the grouping. So why did you put them in two groups? What do you notice? What are similar, what are different between these two? When you're done with that, go ahead and continue the video. Alright, so here is what your two groups should have looked like, and they went ahead and just put them in red as far as one group. So the linear expressions are in red, and the nonlinear expressions are in black. And the equations that contain an exponent of x other than 1 were put in one group, and the other equations were put into another group. And the only difference between the two of them is some of the x terms were other than a power of 1. So if you notice, this is not a power of 1, not a power of 1. This one also, and this one has an x that is not a power of 1. But here we have x to the first, x to the first, 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 and first. So linear expressions in X are a special type of expression. Linear expressions are expressions that are sums, and that is a huge word here because this is going to come up later. They are sums of constants and products of constant and an x raised to a power of 0. Now I know that you're going to say, well, wait a minute, what do you mean raised to a power of 0? Well, it ends up simplifying to a value of 1. So you can have x to the second power as long as there's something that, when simplified, will negate that x to the second power and bring it back to a value of 1. We'll talk about that later. Nonlinear expressions are also sums of constants and products of a constant and a power of x. However, nonlinear expressions will have a power of x that is not equal to 0 or 1. Because remember, x to the 0 is 1. Alright, the reason we want to be able to distinguish linear equations from nonlinear expressions is because we will soon be solving linear equations. Nonlinear equations will be a set of equations you will learn to solve in Algebra 1, though we will begin to solve simple nonlinear equations later in Module 7. We also want to be able to recognize linear equations in order to predict the shape of their graph, which is a concept we will learn more about later in this module. Alright, so for example 1, and there's about 4 or 5 examples, and these will be in your math journal. A linear expression in X is an expression where each term is either a constant and x, or a product of a constant and an x. So for example, the expression 57 minus x is a linear expression because it is a sum of a constant, which is 57, and x. Now you might be saying, well, wait a minute, this is negative or subtract. Well, remember, all subtraction problems are addition problems, so we would say this is 57 plus a negative x. So it is the sum of a constant and an x. However, the expression 2 times x squared plus 9x plus 5 is not a linear expression. That is because the 2x squared is not an expression in x, or a linear expression in x, it is an exponent raised to the power of 2. So again, this is because terms of linear expression must either be a constant, which this is a constant, and x, which this is an x, or the product of a constant and x, which 9x is. The term 2x squared does not fit the definition of a linear expression in x because it is x to the second power, not to the first power or to the 0 power. And remember, this is x to the 0 power because there is an x here. It just, you can't see it because x to the 0 power is 1. And so we don't need to show it. All right, example 2. Let's examine the expression 4 plus 3x to the 5th power more deeply. To begin, we want to identify the terms of the expression. So how many terms are there and what are they? So how many terms and what are the terms? Well, there are 2 terms, 4 and 3x to the 5th power. How many terms comprised of just constants and what are they? Well, we have 1 term, and that is the 4. The 4 is the constant, and it's the only constant. How many terms have coefficients, and what are they? Well, again, a coefficient is attached to the term with an x, and so there is only 1 term with a coefficient, and that coefficient was 3, because it was 3x to the 5th power. So is 4 plus 3x to the 5th power a linear or nonlinear expression in x? Why or why not? Well, it is an expression that is nonlinear because the sum of the constant and the product of a constant and a positive integer is a power of x greater than 1. So we have a sum, we have a constant and a product of a constant. It just so happens that the power is greater than 1, so it is nonlinear, but it is a nonlinear expression. All right, example 3. How many terms does this expression have, and what are they? So if you count them up, how many expressions do you have? Well, actually, how many terms do you have? As is, the expression has 4 terms. Now you might be saying, well, we can simplify this, and yes, we can, but as it is right now at this first stage, it has 4 terms. The 7x, a 9, a 6, and a 3x. Now, this expression can be transformed using some of our basic properties of numbers. For example, if we apply the commutative property of addition, we can arrange the terms. So now we can put our like terms together. So we will put the 7x and the 3x together and the 9 and the 6 next to each other. So that's commutative property. And then we can associate them by putting the parentheses around them to show that we are grouping them. And now we can use the distributive property to show that we can add 7x plus 3x. Because what we're doing is actually a reverse distributive property. We have an x that is in common, so we pull that out, and now we can add the coefficient 7 plus 3. That gives us our 10x, and then plus 15. So how many terms with coefficients does the expression 10x plus 15 have? Well, now we're down to 2 terms. And 1 term has a coefficient, which is 10. And that is what we're saying here. So the expression has 1 term with a coefficient 10x. For this term, the coefficient is 10. Is 10x plus 15 a linear or nonlinear expression in x? Well, the expression is a linear expression. And notice how it seems like we're repeating ourselves, but again, you want to get into the habit of answering a question with the question as the first part of your answer. Because when you do the PARCC test and you're asked to do written response or constructed prose response, as it's called, they want you to include the question as part of your answer. because the sum of the constants in the products that contain x is to the first power. So here's our x, and it's to the first power, so that means it is a linear expression, also because we have a sum of a constant and a power of x only to the first power. All right, example 4. How many terms does this expression have? What are they? So we have 5 plus 9x times 7 plus 2x to the 9th power. Now you might think at first that there are 4 terms here. Actually, it's 3 terms because 9x times 7 is considered one term. Remember, a term is always separated by an addition or subtraction, because remember, subtraction is addition. So one of the big things I've been telling you, if you have a subtraction problem, turn it into addition, because then that tells you what your terms are. 5 plus 9x plus, or times 7, that's one term, plus 2x to the 9th power, that's your third term. So there are only 3 terms here. How many terms with coefficients does the expression have, and what are they? Well, it has 2 terms with coefficients, and here we can actually, because it's 9 times 7 times x, we can simplify it. So 63x and 2x to the 5th power, so the coefficients are 63 and 2. So is this expression a linear or nonlinear expression in x? The answer is it's a nonlinear expression because the sum of the constants and products that contain x raised to a power that is greater than -1. So we have this term here with x to the 9th power, and that tells us that it is a nonlinear expression. All right, example 5. Is this expression 94 plus x plus 4x to the -6th power minus 2 a linear or nonlinear expression in x? Why or why not? Well, you might have first said that it is neither, not a linear or nonlinear expression in x because of the -2. It is not a sum. However, remember, as I was saying before, subtraction is addition, so we can write this as plus a -2. Therefore, it does fit our definition of nonlinear. So we do have a plus, and this becomes plus a -2. And because we have this -6, it is a nonlinear expression. All right, example 6. In the expression x to the first power plus 9x minus 4, is that a linear expression in x? Well, yes, it is, because x to the first power is the same as x. We just dropped the 1. And again, -4 or -4 can be written as plus a -4. So again, writing this as addition plus a negative constant. So what powers of x are acceptable in the definition of a linear expression in x? This is just a review question. Remember that it is x to the first power, because only a power of 1 is acceptable. And by definition, x to the first power is just x, which we defined way back in our unit of properties of exponents. All right, so that's it for the note-taking. Now you get to apply your new craft to exercises 1 through 12. Remember to define your variables before stating the problem using symbolic notation. So this is a practice and of you getting in the habit of starting your problems with let x be what. Okay, so, and then check your answers when you are finished. All right, here are the answers to exercise 1 through 12. So you had to change the expression in words to a mathematical expression. Let x be a number, because it's talking about the sum of a number and 4 times a number. Then that means x plus 4x is a linear expression. All right, so here's 1, 2, and 3. And here is 4 through 9. Once you're done checking that, continue the video. And here is 10 through 12. And remember, if you have any questions, you can always bring them to class and ask. All right, our summary. We have definitions for linear and nonlinear expressions. We know how to use the definitions to identify expressions as linear or nonlinear. We can write expressions that are linear and nonlinear. And we are done with this lesson.